Hi students, today let me discuss you important topic dipole moment. Dipole moment is a very important feature of molecules which is a concept can be applied in inorganic as well as organic molecules. Dipole moment is simply defined as dipole moment mu is equal to product of charge and bond length. That is mu is equal to E into D, where E represents charge on the atoms, D represents bond length. Dipole moment has a unit. Unit of mu is capital letter D or dB. 1D has two magnitude. One is 10 raised to minus 18 ESU, electrostatic unit centimeter. ESU is the unit of charge, centimeter is the unit of bond length. Another SI unit is 3.33 into 10 raised to minus 30. 3.33 into 10 raised to minus 30 coulomb meter, where coulomb is unit of charge, M is the meter is the charge of bond length. Now, dipole moment is a vector quantity. Vector quantity is a quantity which has magnitude and direction. The direction of the dipole moment is represented by an arrow sign with a cross mark here. The cross mark represents positive part. This arrow point represents negative part or negative atom of the molecules. For example, let us take HCl molecule. HCl where hydrogen has the positive charge, partial positive charge, chlorine has the partial negative charge. Why hydrogen has a partial positive charge? Because electronegativity of hydrogen is less than electronegativity of chlorine. Therefore, to draw the direction of dipole moment along a bond, put the positive charge on an atom which has lower electronegativity than the other atom which has higher electronegativity. Therefore, direction starts from lower electronegative atom to higher electronegative atom. The cross mark, positive cross on atom which has lower electronegativity. This pointing on the atom which has higher electronegativity. Now, what is the meaning of dipole molecules? How dipole molecule exists? What is the role? Look at here, two molecules. One is N2. N2 has two nitrogen atoms. Both atoms are nitrogen, same atoms. Therefore, their electronegativity is same. Therefore, we cannot say one nitrogen atom has positive charge, another nitrogen atom has negative charge. It is illogical. Therefore, we say that this molecule has zero dipole moment. Now, what happens when you take zero dipole molecule like nitrogen in a container? They will orient randomly. But take the HCl molecule which has non-zero dipole moment. There is a negative part chlorine and a positive part hydrogen. Such molecules are called polar molecules. When polar molecules are taken, they will be well aligned like this. Look at it. One HCl, the neighbor is another HCl. This hydrogen always come close to Cl. This well alignment of the molecule is possible when such molecule has a non-zero dipole moment. Now, dipole moment of polyatomic molecules. So far we discussed the dipole moment of the bonds. Suppose a molecule have more than one bonds. Each bond has individual dipole moments like mu1 and mu2. Therefore, the net dipole moment of the molecule is equal to square root of mu1 square plus mu2 square plus 2 mu1 mu2 cos theta. What is this mu1 and mu2? Let us take an example, water. It has two bonds, this bond and this second bond. This bond has a dipole moment mu1, this bond has a dipole moment mu2. Fine. This bond has a dipole moment mu1, this bond has a dipole moment mu2, and theta is the bond angle, and theta is the bond angle. Fine. And theta is the bond angle. Now, what will happen? Mu1, mu2, 2 mu1, mu2 cos theta. Now, theta is equal to which theta is called bond angle. Now, see this equation mu is equal to mu1 mu2 mu1 square plus mu2 square plus 2 mu1 mu2 cos theta. Now you have two extremes. Theta can be 0, cos theta is equal to 1. Therefore, net to my dipole moment is equal to mu1 square plus mu2 square. This is the maximum dipole moment. Another option is theta is equal to 180. Bond angle is 180. Cos 180 is equal to minus 1. Cos 180 is equal to minus 1. Therefore, net to dipole moment is equal to mu1 square minus mu2 square, which is equal to almost 0. Therefore, maximum dipole moment when theta is equal to 0, minimum dipole moment is when theta is equal to 180. Therefore, you can make this equation mu, that is dipole moment, inversely proportional to theta. You can make this equation dipole moment inversely proportional to theta. We can take another specific example. Look at this example. Consider the benzene. It has 4 chlorine atoms, C1Cl, C2Cl, third carbon atom Cl, and fifth carbon atom Cl. Suppose Cl, all Cl bonds are identical. Cl dipole moment value is 1.5 d. Individual Cl dipole moment value is 1.5 d. What is the net dipole moment? Therefore, it is a sum of dipole moments of all these. Have you noticed that this C2Cl and C5Cl are in an angle 180 degree, and their direction is in opposite. These are in opposite, just like two parties in a tug of war. Two parties in a tug of war. Therefore, dipole moment of these two bonds are cancelled. Now we wanted to calculate dipole moments of these two bonds. For that, you can apply this equation. Mu1 square plus mu2 square plus 2 mu1 mu2 cos theta. This is 1.5, this is 1.5, this is 1.5, this is 1.5. Now only the cos theta. Since we are going to calculate the dipole moment of these two bonds, their angle is, look at, their angle is this is 60, therefore this is also 60, total 120. Therefore their angle is 120. Okay, 20. Therefore cos 120 is equal to minus 1 pi 2. Now you apply the equation here. You just square the equation. Mu square is equal to, therefore you can remove this square. Mu net to square is equal to mu1 square. What is a mu1 square? 1.5 square. Mu2 square plus mu2 square, 1.5 square. 2 into mu1 mu2, 1.5 into 1.5, cos 120. Cos 120 is equal to minus 1 by 2. Therefore minus 1, here a minus 2 and 2 cancelled. Minus 1.5 square. Minus 1 point. Therefore 1.5 and 1, another 1.5 cancelled. The net is, mu net is equal to 1.5 d. Mu net square is equal to 1.5 square. Now the next is dipole moment and ionic character. Dipole moment and ionic character. Ionic character of a bond. We have two dipole moments. One is mu calculated and mu observed. Mu calculated means you calculate the dipole moment using the equation. Charge into bond length. charge is taken as 1.6 into 10 raised minus 19 coulomb. Now percentage of ionic character is equal to mu observed by mu calculated into 100. Mu observed by mu calculated into 100. Observed dipole moment will be given. This is calculated. Suppose you will give the bond length, only bond length, and observed dipole moment. Charge can be taken as this value. Now polarity and dipole moment. There are a lot of concepts included there. If mu net dipole moment of a molecule is 0, such molecules are called non-polar molecules. Example, CCl4, CH4, benzene, PCl5. If mu net not is equal to 0, such molecules are called non-polar molecules. These are the examples. Chloroform, dichloromethane, water, ammonia, etc. Now dipole moment and structure. Dipole moment and structure. Suppose any polyatomic molecule, any elements, dipole moment of elements are 0. What is elements? They contain same type of atoms. Dipole moment of elements, polyatomic molecules having same atoms, that is elements, are 0. Whatever number of atoms are there, but their dipole moment is 0. Second, dipole moment of symmetric molecules are 0. Dipole moment of symmetric molecules are 0. Mu is equal to 0 for symmetric molecules. What is the meaning of symmetric molecule? They have structure like a trigonal planar, tetrahedral, trigonal bipyramidal, octahedral. They have the structure trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral. Structure BF3, CH4, PCl5, and SF6. Dipole moments of these molecules are 0. Now, mu is equal to not equal to 0 for unsymmetric molecules. Mu not equal to 0 for unsymmetric molecules. What are the examples? Chloroform, dichloromethane, PF3, SF4, xenon OF4. Dipole moment of these molecules are not equal to 0. Look at here. This hybridization is sp3, but it is not symmetrical because atoms around the carbon are different. Its hybridization also sp3, but it is not symmetrical because atoms around the carbon are unsymmetrical. It is unsymmetrical because it's a pyramidal shape. It is unsymmetrical because it has a seesaw structure. It has square pyramidal structure. Therefore, you can select the molecules having shape, pyramidal, bent, seesaw, square pyramidal, etc. And the molecule having different types of atoms around the central atoms. Another point, dipole moment of para and trans structures are 0. Dipole moment of para and trans structures are 0. This is a molecule having para. Its dipole moment is 0. This is trans structure. Dipole moment is 0. Now, look at here. You have given ortho, meta, para. This is 0 dipole moment. Ortho has maximum dipole moment. What is the trick? Dipole moment inversely proportional to angle. What is angle here? 60, 120, 180. When angle increases, dipole moment decreases. Thank you for watching.